Recording again, and let's go back to some slides. Okay. Okay. Great. Okay. I need to make this full screen. Boom. Boom. Okay. Right. So there's a couple of topics that I'd like to discuss today. One of them was something we actually saw last time, but it wasn't fully resolved. And well, okay. So the first thing is I wanted to emphasize what Chen-Wei Chang just said, which is there's this hierarchy of types in Scala. All of these are examples of any val. And Winchell is right that I think long, float, double, int, and short, maybe? I'm not sure about short, are all examples of numeric.
I think short is also.
Short also, okay. These are any val. So we could have a thing called, val v any val. Let's try that. Oh, okay. Only class is kind of declared but defined. Two. Okay, fine. Or I could give given it 2.0, be perfectly happy, or I could give it some value that would be a short, and I can't remember off the top of my head how to specify that. But it's the point is it can handle any of those types here, and then there can be an any ref that will handle these sort of things. These values have a special status. But fortunately, unlike in Java, there's no going back and forth between like a capital I integer and a lowercase I. One's a value, one's a reference to a value. In Scala, you don't have any of that nonsense, which is beautiful. This whole unboxing thing, for whom that's a meaningful statement. Any ref will get you a whole bunch of different classes, including classes you defined here. And then there's some additional special handling for things like null values, which are best handled in a different way in Scala using options, or either, or try, as we'll see, which is just so much more beautiful and compelling and less buggy. The inventor of null value says it was $1 billion mistake, and I respectfully disagree. I think it was several $1 billion mistake. And Scala is a much better way of dealing with it, as befits a functional programming language. Nothing basically can be used to indicate sort of the absence of any particular type. Okay, great. So a couple further things here. We saw last time reload file here. Last time what we saw was a situation where I wanted to show how you could expose an accessor, something that allows you to access a changing value, but not allow outside people a way to change it. And the challenge there was, first of all, it needed to be a var. Why did it need to be a var? Well, vars for classes here, remember, you can specify when you're indicating this, you can specify one is a val, one is a var. By default, they're vals, okay? And val parameters will create val fields, var parameters will create var fields. And the basic deal is var and val are determined by whether or not you want to change it, okay? Whether or not you want to change this thing. In other words, whether it's static, it's fixed, or dynamic. If it's dynamic, if it has to change, you want a var. If it's static, you want a val. However, that's orthogonal to the choice, do you want it to be publicly visible that you can change a varying value? So you can have a var where you don't want to allow outside people the ability to change it, just to look at the value. And I was trying to show you that issue yesterday, last time, where you want an accessor but not a setter. And after some discussion and Winchell, finding a solution that agreed with kind of the one that informally we settled on last time, Well, there was Krugerian contribution, but Winchillian wonder was also involved. Okay, so ladies and gentlemen, what we had last time was something where we were trying to make something accessible. And what we did here was we ended up having, and I'm going to show you here, right here, okay? So this is the correct where we have an aspect of state that's changing over time, but we don't want to define a setter for it, okay? So we had something like this, and I will put this on multiple lines here as I want. But you'll notice that we declared something private here. We declared this private, meaning there's a getter and setter, but no one from, it's a var, so there's a getter and setter, but they're private. No one from outside can call them, okay? And then we declared a public one, which can access that variable, a public getter, something that can get the value of this variable. Actually, and this is going to call this underbar income here. But this is going to be visible publicly, the getter, but the setter we did not expose. So in short, if you want to expose the getter, the thing to get the value, but you don't want to expose the setter, make it private, make it a private thing, and then create a public thing that just gets the value.
Question on that.
Yes.
Does that allow you to, does that still avoid the need for parentheses when calling these functions?
Okay, so one thing I made clear yesterday was, or last time, I tried to shed light on was this issue, Scott, that has to do with this. If you declare a function with parentheses after, begin paren, end paren, that doesn't take any arguments, you can call it with parentheses or not. You can get its value, okay? So again, this is the very particular case of functions that take no arguments. They don't need any information to do their job that's provided as an argument. In that case, if you declare it with parentheses, you have the option of calling it either way. If you declare it with no parentheses, it's still a function, but, well, method, technically, but you can't give it parentheses. This would not be allowed. Okay. So that's a little.
So it's the opposite of what
quirk. Yeah. That's right. And this is an example of that principle. Although I think actually this should be this should really be okay. No, this is correct. This is another point that's being accessed. This is the one that I was talking about from last time. Okay, so that's a little bit of sort of a loose end from last time that I want to clear up. So this is, I'll stop that. I'll